much. So I've, of course, changed the title of my talk because I had to, but I'm going to try and get through two different projects that are a bit interrelated in the amount of time I speak very quickly. So if I move past something that's not, that you missed or didn't understand, please interrupt me for that or anything else. I also have typically given these talks to environmental scientists now, which is where I'm working. So I may be a little too heavy on explaining some of the network terminology, which I'm sure you're all familiar with, and a little too light on explaining some of the environmental conditions. So if anything is unclear, please stop me. But in my postdoc, I got interested in this type of collaborative management, specifically in the environmental sciences. And in environmental policy, what this means is that you typically tend to have lots of different groups, many land managers and interested parties who have sought approaches for more cooperatively resolving natural resource problems and conflicts. So you've got multiple parties joining together voluntarily to identify environmental and natural resource problems at all different scales and trying to improve these solutions through working together. And this is from a Government Accountability Office report in 2008. So just some examples to kind of cement that this is an important case, this is an important field where a lot of people are interested in working. From one group that I've had some interaction with, IFPRI, these are a couple of examples of where they've held these kinds of collaborative management programs in forestry. So they say that they've got 63,000 groups in India working to collectively manage forests, 9,000 in Nepal, and 2.2 farmers working on 2.2 million hectares in Brazil. So a lot of people are involved in these kinds of endeavors. Okay. So I'm going to talk about two different projects related to collaborative management. The first is at the individual level, and the second is at the organizational level. The first is what was in my original title, this adaptive rangeland management project, where individuals are meeting to try and work on collaborative decisions together. And the second is looking at a set of organizations who are working together in collaborative management. And I think you'll see that both of these projects are looking at the same kinds of problems, albeit at different scales, and also connected by a focus on computational methods, rigorous hypothesis testing, and that a lot of the methodology is pretty similar. So to go into collaborative management at the individual level, here's an example of a program in the United States from the Bureau of Land Management. You don't have to read all the specifics, but basically they've got a whole set of materials for people about how to bring together different stakeholders in a neutral ground to try and address problems. These are going on all over the world in the US. And in particular, I got really interested in one outreach program that was trying to work with ranchers, conservationists, and government people in Northern California. So this is a photo from our outreach site where we've got two of my collaborators, Ken Tate and Leslie Roche is back here, talking to a whole group of ranchers about their practices on the land and this site in Northern California and what they could do to work with government about it. Here's some work from a colleague that's looking at this process of these kinds of collaborative management teams, that you've got individuals who have different management goals, different strategies, they've got all different kinds of influences from the social and ecological system. These all get debated continuously, which changes people's ideas, maybe lets them work together in a group, and then affects this kind of management outcome. So this is the process that I'm interested in for the first project. And what we did was, it's really difficult to go to ranchers. I learned way more about ranchers and cattle than I ever thought I would. But you can't go up to a rancher and say, tell me about your management strategy. They just don't answer those questions. It's vital to their economic livelihood. They don't want other people knowing their business. So what we did to try and measure this and look at how these ideas adapt is we set up an experiment. So we're really trying to understand, how do different participants integrate different types of knowledge? Is group deliberation useful for building agreement or consensus in these management decisions? And then what kinds of decisions can we expect from these types of groups? So here are some details of the first experiment that we ran. We brought a group of stakeholders to a neutral property, the Sierra Foothills Ranch Field Station, and asked how they would manage some separate sections. Then they discussed their ideas in different stakeholder groups, and my plant science colleagues are actually implementing their suggestions on the property. So we split them into 4 different groups, and we've got 4 different parcels of land that are actually being independently co-managed by these groups of people. So we can actually study the adaptive management process. So we've got 3 different types of stakeholders: ranchers, which are these private individuals who run their own ranch; conservationists, who typically work for non-governmental organizations; and then we had government people. So I told you we had 4 different teams. We have one that's homogeneous from each group, and then we've got one mixed group to try and see, when you really do have opinions from all these different types of people, how does that group change relative to the homogeneous groups? So they showed up at our field station. They answered a first survey on their background and details. They visited 2 different sites, a woodland and a grassland site. And then they answered surveys about their goals. What would they do given the amount of cattle we had on the land and what they saw from the land itself? Then we split them up into groups that they could discuss. I've got 2 different numbers because we held 2 different iterations of this. So on our first experiment day, we had 9 in the rangeland management group. Those are typically the government people, 6 on the second day, and a mixed group. Then they answered a final survey that pretty much said, here's what you told me the first time around, make any changes. And I asked a couple of questions here. I asked what goals they would set for the property. I pulled this out, sorry. And I also asked for each goal, what are the methods they'd use to achieve it? All right, so first, my plant science colleagues were very interested just in what are people's management ideas. What do they want done with the property? How cohesive are these different homogeneous groups? How do these goal and method nominations change after discussion? How do we compare the mix to the homogeneous groups? And then, the main goal is what predicts belief change or learning in these teams. That's the end goal that we're interested in. So to look at people's management ideas, we had 294 different goals that people listed before discussion, 303 after. My colleagues coded these into 8 different goal types, and I've got some examples at the bottom. So first off, how similar are the different groups? How do their goal and method nominations change after discussion? Well, here's just a spread of the different goals the groups had, and you can see certainly, everybody put down livestock production. Even if you were a conservationist, you recognize that this is a really important goal for the land. So some of these goals have really similar levels across all of the different groups, and some, like the one far on my left, your right, to plant diverse native species, was a little bit more dominated, you can see, by the conservationists in this teal as opposed to the red. When we look at the similarity and do a correspondence analysis, here what I've done is placed the goals that were named by the members of the different groups with the kinds of terms that they used. So the closer you are to forage production, the closest being this rangeland, the government people before discussion, means that more of these groups nominated a goal that we counted as a forage production. And so we see first off that there was not too much change. Certainly in the ranchers, you see there was very little before and after change. Not too much going on, but certainly like the conservationists stay more like the conservationists before and after than any particular change. So in order to say, okay, what's the significance of the distances between these, I turn to a simulation and a very simple baseline model. I simulated 1,000 possible other scenarios given the popularity of each goal, the number of people who nominated it, and given the number of goals each respondent mentions. This was important because the ranchers tended to have the fewest nominations. In general, they tended not to want to sit at a computer and write down answers. So I wanted to try and control for that in how similar I thought the ranchers were to each other and to the other groups. All right. So the y-axis here is the number of disagreements, the number of times I said I think livestock management is important and you didn't include it. The average number of disagreements between each pair in the group. So here we see that the amount of disagreement decreased in the ranchers from before to after. So they got more similar. But the question is that actually significant? When we use 1,000 permutations of each data, conditioning on the number of times it was mentioned, we actually see that for the ranchers, this falls within what we would expect just based on the number of goals each person mentioned and the popularity of each goal. So I wouldn't actually say that they got significantly more similar to each other just discussing these ideas for 2 hours. Similarly, when we look at the rest of the data, I'd say, okay, nothing's really going on that we couldn't have predicted by chance. Now turning to methods. We had 360, yes.
These are all for rancher.
No, sorry, this is the rancher set. So these are the differences between ranchers before discussion and after. This is for the government people, the Rangeland group, the conservationists, and then here's our mixed group. So you can see the mixed group got slightly more different, but still falling within what we could have predicted would be the number of differences they'd have just from throwing down the goals they mentioned at random. Yes?
Is there any significance that the mixed group, even in the random sense, had a different trend of that mean? Is that important in some way?
Given how close it is to the random mean, I'm not going to ascribe any interpretation to that slight change. I'm going to say it's perfectly predicted by our null model. End of story, at least as far as I'm concerned. Which is a hint that maybe there is something else I'm more interested in coming later. But no, I wouldn't read too much into that. I would say, yes, they differ more slightly after, but not in any way that we would really consider different from just a random picking of goals. And it's pretty similar for methods. We've got a lot of different methods, got characterized into 9 different groups. One nice person said just burn the grasslands down. Sounded good to me. Similar here. Again, we see from this picture that, conservationists were big on grazing management, planting natives, fire. The ranchers were really involved in grazing intensity. They wanted the cattle out on the land as much as possible. This all made sense to my colleagues. I don't read too much into it. But when we go to the simulation, what's interesting is that the ranchers all understood and were more similar in their methods than we'd ever expect them to be by chance. And this is what a lot of my colleagues would read into as experiential knowledge. They don't care about the goals. They all have the same kind of goals. What they really understand is the methods. They all agree on what should be done, as opposed to the other groups. But even with this, you could say, okay, there's some differences between the groups, some change in the number of goals, not terribly interesting, and has absolutely nothing to do with networks, which is what I study. So, relating actually their goals to methods. What are the ways they would actually approach each of these solutions? Nicely, and the point of this part of the study is, we see a lot more change in these kinds of links between the concepts than we do in seeing people add more goals or add more methods. We see a lot of change here. Now, granted, I'm going to refer to this as learning. That's stretching it a bit. We can't distinguish between whether you just got reminded of a link that you already knew about or you actually learned something new from someone. But this is still the most evidence of change as a result of discussion. So you got to take that at face value. But what looking at these links allows me to do is bring in a relational belief framework, which I'll show in a minute. And it follows what we would believe anyway, that the support for specific goals and methods is interrelated, that these are not separate concepts, but that which methods I'm interested in is related to which goals. So here's an example of one person before discussion. He said that, let's see, grazing management is one of his goals, to up the grazing management, and he felt that planting natives would really be a method that would help. So methods are in triangles, goals are in squares. And this is his model of which methods would actually get to which of the goals he wanted to achieve. So this is before discussion. Here's the same guy after discussion. So now I can actually say, okay, maybe there is something going on. And this is a theme throughout both of the projects that I'll show today, that it's more, sorry, yes?
So this data came from like a computer, a survey they did on the computer after the discussion, right?
This came from before the discussion.
That on the left before.
And that came from him looking at his answers before the discussion and being able to change them. I didn't reissue a whole new survey, because if you ask me to answer the same 20 questions 2 hours apart, I would say, screw it, I'm going home. So we really stacked the survey towards no change. All they had to do at the second one was say, yep, all my answers are the same, and they could leave. So it was really stacked towards not observing any differences. So the fact that we actually do see some was a big relief to me. But what I'm arguing here is that clearly what you can get from these kinds of collaborative decision processes show that the linkages between the concepts and somebody's understanding of the problem can be the site of the more change, more learning, and might even be more important to understand what kinds of things result from these processes as just knowing the content of their ideas, their goals, and methods themselves.
Sorry, I might have missed too. So how exactly is it like codified? Like, did that guy actually say like, oh, I think planting natives are great for grazing management? How do you then like extract these two terms?
Right, so they listed a whole bunch of goals, which got coded into these categories. For each goal, I then said, okay, now list the methods you would use to achieve that. Then they went to the next screen, which says, here's your second goal. Here's all the methods you listed before. Check any which apply, and add any new ones. I've done other versions of this where people are actually given a blank computer screen and they can draw out the maps that look like this. But this was done in an iterative written survey on a computer.
Did you simulate different codings to see if codings have an effect?
We've done some sensitivity analysis to that. So I had my colleagues go through and code, all right, these are the two most similar goals. So when somebody wrote plant natives and somebody else wrote plant native grasses, those were the two most similar. So I've got an ordered design of which pairings they like the most. So far, we've just done it with this coding with the 8 and 9 different groups. No, that's not true. We did another initial set with a much sparser, with I think 15 and 20 categories. But yeah, we've got that. That's definitely something that we need to do because it is sensitive.
Sensitivity so far, or has it been pretty robust?
The big difference becomes when you look at the different categories. The methods are fine. The goals have some sensitivity to this plant natives group. So here we have plant diversity, plant diverse types of oak trees, and plant natives. If all of those get combined, the differences between the ranchers and the other groups don't really change, but the conservationists are then different because they so overload that category. So I have seen a little bit, and if you pool all of those, then the conservationists move a little further away from everybody. The links and the change in the number of links, however, you are condensing some of the nodes, but it's not, that effect can't disappear. Because all it would do to this is take 3 of those nodes and group them together. There are some ways where you could decide that would make, it's certainly plausible that you could have a specific configuration where that would make a huge difference, but not with the really gross baseline model I've been using that's going to assume that number of links anyway. All right, so here's the change. So basically, I want a way to measure the differences between those two groups in the same way that I was doing with goals and methods. And for that, I use the pretty simple network measure that's Hamming distance. So if we've got two networks, network A and network B, network A has 5 edges, network B has none, they're at a difference of 5. If I add an edge to network B that's not present in network A, then its difference goes up to 6. All right? So that's just Hamming distance. It's a simple way of measuring how these people's cognitive maps are really different from each other. If I go back to the example where we've got one individual's map before discussion and his map after discussion, he's at a difference of 40. So that gives us a way of measuring the differences similar to the way I was doing with the goals and methods before. And I do the same kind of simulation. I control for the popularity of links and the number of links per person. So basically conditioning on the row and column marginals, and I simulate it as networks. And we get very different results where I would actually interpret that we've got some significant differences going on. You see that even though the differences, the number of differences that the ranchers have, the raw number increased. They went from being significantly more different than we'd expect by chance to be significantly more similar than we'd expect by chance. So that reversal, to me, actually says that the ranchers have added these links in such a way as to be closer to an agreement on what the system looks like. Yeah?
Maybe you're about to say that. You said they went closer to agreement, but doesn't the average number of disagreements going up?
They became closer to agreement than what we would have expected compared to the baseline. So the total went up, but whereas here they were significantly further apart than we'd expect just given their number of mentions, here they're significantly closer than what we'd expect just given the mentions. And so, yeah, I'm going to interpret that as an increase in coherence in the system. They've now ordered themselves in such a way to be more like each other given their options if we put those constraints on the system. So we've got two groups that did that, the ranchers and the mixed group. And interestingly, we've got these two groups in the middle that started out actually more coherent and became less so. So this is the point that I'm at right now with this project. It's a network story. There's much more change in the goal method links. And that groups added a lot more links. Every single group and every single individual added some links after discussion. But the ranchers and the mixed added them to become slightly more significant when compared to the baseline. And what I was hoping to then be able to present today, but is still far too rough, is to take this in the future directions. You know, clearly I have these two different regimes. Two groups moved one way, two groups moved another way. What's nice is that I actually tape recorded their conversations and had coders sitting in there recording what they were talking about and who was talking to whom. So the next phase of this project is to look at what roles people played in the conversation and whether that has any relationship to the changing of the mental models. And the other thing is to repeat with tons more groups, because certainly 4 groups on 2 days, 8 total, is not going to really convince anybody of anything, but just kind of push them towards an idea. So those are the future directions with this project. The second project that I'm going to discuss kind of zooms out. It says, okay, let's take this collaborative meeting, this group where people try to negotiate how to make management decisions, and instead of viewing each individual as a node in my network, let's view that organization, that discussion itself, as a node. We've got lots of instances of these places where people are debating these kinds of management decisions, and these things get linked together in kind of a policy network, these sites where people are debating management ideas and decisions. And it's been noted in a lot of work on this that we've got huge problems with institutional fragmentation. One body, one group of people makes one decision, another group makes a slightly different decision, they can't be rectified, etc. But there's a lot of interest in doing these kinds of things. So this is a quote from one of the groups in my next, in the next project where I'm looking at a network of these kinds of organizations. And they said, look, diverse stakeholder organizations and public input was instrumental in helping us to develop actually feasible policy. So let's say, here's my past experiment. It's one group of people making management decisions. And there are tons of these sites going on, lots of different ones. Say this is blue, that was my color for conservationists. We've got lots of NGOs meeting together to try and establish what's the best environmental policy. The case I'll be showing here is on water in Northern California, a very highly contested framework. And then we've got a whole bunch of other groups who are made up of ranchers, say, for the red. That these are, another group of different kinds of stakeholders who met and all decided very different things. And we've got some links between these settings because, say, person A or organization A, who was in the first circle, also attended the other meeting. But if you notice, blue is only connected to blue, red is only connected to red. This was the situation we had in Northern California for a long time, where we had government people deciding what needed to be done with the water, private people who actually own the land that the water ran through saying, I'm not doing that. And so we had a big problem of institutional fragmentation. So in Northern California, they tried to set up a different type of policy institution. This third group that would actually try and knit these two different groups together, collaborative partnerships. You may have heard of CalFed. That was one of the biggest in Northern California. That was this type of an organization that invited all these different groups of people to try and sit together at the same table. So when I started looking at this bigger network, and I'll talk about the specific data in a minute, the concept of interest is really this brokerage process. This knitting together of all of the different parties of interest. And this is a classic concept in social network analysis. I'm sure many of you have seen it. It's a process by which intermediary actors facilitate transactions between other actors lacking access to or trust in one another. And certainly there's some great movies about the water fights in California. There was no trust in that system whatsoever. And that these brokers play a crucial role in bringing different organizations and actors to the venues where policy is created, thus mitigating the costs of this institutional fragmentation. So brokerage has been recognized as a really crucial part, when you think about, and it was a concept I was already thinking about in the context of the prior experiment. Were the government people brokering between the conservationists and the ranchers? Can I see that in the conversation? Well, can I see it now in a bigger, more organizational scope? So here's the formal concept of brokerage. In a network, you've got three nodes, I, J, and K, and J brokers I and K if there's a tie from I to J, J to K, but no tie between I and K. The only way information can flow to K is through J. All right, this was formalized by Gould and Fernandez in 2 papers, and they added a vertex attribute component. They said what's really important is, especially when you're looking in the policy arena, what types of actors are involved and how they relate to the other actors in this brokerage chain. And that's where we can really start to understand the system. So here's their classification from the 1989 paper. They said, let's say you've got all government institutions here. Then one government institution is coordinating between 2 others. They're working with other organizations that already have the same kinds of goals and interests. But here, maybe an itinerant, a government organization is mediating a dispute between 2 different ranchers. That would be the itinerant brokerage. Representative, the blue is acting as a representative of red's outside interests, 2 other groups, 2 other organizations in its group. And you see the similar logic for gatekeeper and liaison. Okay. But the data that I described has 2 modes. because it's organizations or people attending these different policy institutions. I've got all these different instances, and I'll get to a slide on the exact data before, of these institutions or places where people are debating policy, and then who's actually participating. And the network is formed when people who participate in one institution also go and attend multiple others. So that doesn't fall into the Gould and Fernandez framework unless I convert to a one-mode projection, which I already have discussed with some of you. You know how problematic that can be. So I wanted a two-mode version of brokerage. I've got these organizations and policy institutions. So this is what I came up with, where my institutions are the circles and the organizations or people involved in both are the squares. And you see, first off, the difference between my construction of brokerage and Gould and Fernandez is that representative and gatekeeper are now combined into one group. Whereas before in Gould and Fernandez, the directionality of the arrows separated them. Now they're identical. And while this could be problematic, given that my data was already in two-mode, even if I took the one-mode projection, I wouldn't have directed data anyway. So while I understand that there's some loss of understanding, starting with the two-mode data wouldn't have made that any different. And the second is now I have two different types of chains for each of the Gould and Fernandez categories, one where they're similar in the second mode and one where they're different. One where they're attracting the same types of participants to all the different institutions, and one where it's different. The next interesting thing is that given this new operationalization, I can actually order the chains from this coordinator one, which is the most homogeneous. You've got all the same types of institutions and all the same types of organizations, to the most heterogeneous, where you've got all different. So whereas they just had these 5 different categories, now I can actually look at this more homogeneous to heterogeneous scale. The difference is that here I consider representative and gatekeeper to be more homogeneous because it's the broker that has the extra person in their group. I can explain more about this, but here the broker is the odd man out. Here they've got another ally from their same group. So I'm going to consider representative and gatekeeper more homogeneous than itinerant. So now instead of having these 5 separate concepts of brokerage, I've got a scale. All right, so here's the empirical example that I've hinted at. I've got 146 different forums or institutions that drew on 1594 different actors operating on water issues in the San Francisco Bay Area over these 5 years. They get divided into this vertex attribute set of 8 different institution types, the collaborative partnerships, which is what I mentioned at the beginning, and then a bunch of others, and 16 different types of actors. We got this from a newspaper and article search to find relevant organizations and policy institutions. We identified additional links through their websites, and then actually we also sent them a survey that was used mostly for entirely different purposes, but just as a reality check on this other data. So here are the hypotheses. So these collaborative partnerships or collaborative institutions that were built primarily for the purpose of knitting together the system should be doing the most brokerage, if the system is really working the way they wanted it to. Second, if the point is that we're trying to combat this institutional fragmentation, if the issue is that groups that are different don't talk to each other, then the place where brokerage should pay off the most, where it's the most needed, is where it's most heterogeneous. So now I can actually classify that we should expect to see things on that side of this brokerage scale. And thirdly, going back to what I did with baseline models before, what I'm interested in showing here is that brokerage itself is not a phenomenon due to lower level network properties or other things that we already know are going on in organizational networks. The brokerage itself is something different. All right, so let me try and get through this. So first off, we can just go through and count all of the different brokerage chains, count all of these instances, categorize them according to what I showed before. I'm sure you can look at this and you all understand my point exactly. But the real thing, and similar to the project I showed before, just looking at that empirical number isn't going to tell me anything. It's comparing it to a reasonable, understandable baseline model that's going to be able to give me that interpretation. So what am I going to use? An exponential random graph model. I'm running out of time, so here's my 30 seconds on it. I'm sure most of you have seen this equation. Basically, the intuition is that you'll simulate networks, placing more or less weight on structures with certain features, certain sufficient statistics that I think are important. And then, so we define those sufficient statistics in the numerator, and then we estimate the denominator, because that's the impossible part. Okay, so here are the terms that I'm going to include. We've got edges, which is kind of like your intercept term. I'm going to include density terms for those 8 different types of institutions and 16 different types of organizations, because yeah, government organizations are going to be active at a different rate than scientific organizations. The interesting part about this work and what's different is that we're then comparing it to baseline models that are far more complex than what Gould and Fernandez were able to do. Gould and Fernandez essentially used the baseline model that was in my first project. They conditioned on the row and column marginals. They did something slightly more sophisticated, but that's where it stopped. Here I'm going to look at including terms, the alternating stars, which is a term for centralization in the network, and this alternating shared partners, a term essentially interpreted as cohesion. So we already know that these 2 types of processes go on in networks. My question is, do these lower level processes explain all of this brokerage, or is there really something separate going on? All right, some results.
The analysis with all the terms, or you sort of kind of add them and see, oh, I can still find something extra. Like
Model 1 just has the density terms. I'm not reporting the density terms here. They're vaguely consistent. I'm just looking at the more interesting terms. Model 2 just has the centralization, the star terms. 3 just has the shared partners, and 4 has all of them. Now, I get really annoyed when people present ERG models and don't talk about fit. This was fit in PNet. All of the p-values were within acceptable range to show that the model converged. I do have some goodness of fit statistics. We can discuss that later. So this first model is akin to what Gould and Fernandez fit, slightly more complex because it has the density terms that are missing, but it's basically just saying, given the number of edges, what do we see? What's nice about the ERG framework is that you can actually do some form of model selection. Using PNet, this is done through the Mann-Lehobis distance, and lower is better. So actually we see that the model with the most number of terms, the one doing the best explaining. So that's the model that I'll use as my baseline model. What I do now, like in the first project, is simulate 1,000 different networks from this model, conditioning on these terms of structures, and say, okay, now let's compare my empirically observed brokerage levels to what I get from these simulations. All right, generate 1,000 networks, count up the brokerage chains in each simulation, and compare that to my empirical. That's essentially what I've done in this line, which is to say, how much brokerage, just in general, are in the simulated networks. And what this shows is that the number of brokerage chains in the network simulated from this model account for 67% of what we see empirically. Just a little initial tidbit to show that maybe brokerage is not being fully explained by any of these other models. But we can go a bit more in depth. I've already shown that I've got 8 different types of chains and a whole bunch of different types of institutions. So let's do a test on each one of those types individually. Here are 2 examples. I've got, maybe hard to read, scientific institutions brokering that coordinator same chain, that chain all the way on the left that was the most homogeneous. And so the empirical value, this red line, are the number of brokerage chains of exactly that type where the broker was a scientific institution in the empirical data. The histogram behind it is from those 1,000 repetitions. So you see that the baseline model I chose well explains that amount of brokerage. Not so when you've got scientific institutions brokering a coordinator chain, but with different types of organizations, that second chain in the second most homogeneous chain. So what I'm going to do is try and present all 80 different of these tests, 10 different types of institutions, 8 different brokerage chain types, using a significance key from the figure on my left, your right. Okay, so here are going to be the results. The heterogeneity increases as you move to your right. And here are the 2 results that I showed in the previous screen. So the circle indicates that there was no significance. The downward pointing arrow shows that there were fewer empirical chains significantly than we would have expected under my null model taken from the ERG. And here are all the rest of the results. The size of the triangle is relative to the difference between the empirical value and the mean from the simulation. So it's essentially how big the effect is. So what you can see first off is these collaborative partnerships that were set up specifically to be brokering diverse types of groups. Not only are they doing a lot of the most heterogeneous types of brokerage, they're doing it across the board. They're just brokering everybody more than we would have expected just from the baseline model. So I'm going to find positive evidence for my first hypothesis that these collaborative institutions are associated with the highest level of brokerage. Secondly, what I'm going to argue is that you can block these results in such a way so that we see as we move towards the right side of the screen, as we move towards heterogeneity, we're seeing more brokerage that can't be explained by the baseline model. So there is a tendency for these organizations, for these institutions to be placing themselves as more heterogeneous brokers, whether they realize it or not. So I find some support for the second hypothesis that brokerage is concentrated among these most heterogeneous broker chains. And finally, that third hypothesis, I think I've well shown that the baseline model that accounted for centralization and cohesion still resulted in a lot of unexplained brokerage when compared to my empirical data. So it shows that brokerage is not just a result at random of these lower level processes. Okay, so that's the results so far. The future directions are, more of a understanding of what the institutions who are doing the brokerage actually think is going on. I've got a whole bunch of qualitative sociologist colleagues who are doing interviews and different things, so hopefully we can mix my results with theirs. Secondly, I'm really interested, this is a static, the data itself is dynamic because we went from 2005 to 2010, but I'm just looking at a static version of it, just putting all of that data into one network. The dynamics of the system are going to be crucial. And there's one paper published on looking at brokerage in a dynamic framework, and that would be really interesting to do here. Okay, so even more future directions. Looking at both of these projects together, what I'm really excited about is being able to move from how brokerage or change in these individual processes, how these individual mental models then percolate out into affecting policy decisions of the system as a whole. So more work on trying to really link up how these individual collaborative partnerships or collaborative management teams actually affect the system more broadly. And then on a more methodological note, you saw that I used a much more sophisticated baseline model in the second part of the project via the exponential random graph models. The next part of my research is to take that back to the first project and say, well, we've got these mental models. What does centralization mean in that setting? What does cohesion mean when you're talking about ideas, not talking about individuals? And then what are the appropriate baseline models there? We've got very different kinds of mechanisms when it's not well, I'm your friend because we already have friends in common, but one person is thinking about their own concepts in their head. So how much does that affect what types of terms we should be looking for in our baseline models? All right, thanks.